Hi everyone, I'm Jeffrey Land, a software designer on the data logger project. Next to me is Jacob Juarez, the other software designer, Gerardo Almazo, and Arush Singh, our hardware designers. For our project, we designed and fabricated a data logger, which will read in data from two data streams. Now imagine device A and device B. Device A communicates with device B, and device B with device A. Our logger listens to the communications between these two devices and logs it in through two data channels. For our performance metric, we must be able to read data at 1 megabaud. Now that is quite fast, and on the slide it says we can achieve this speed although data is dropped. That's outdated. We're no longer dropping data, so it's good for us. We must be able to accept data from RS-232, RS-422, and TTL data communications, and write this data to a micro SD card using the SPI protocol. Our project can be powered by a 9-volt battery wirelessly or with a micro USB cable. The reason we chose a 9-volt battery is because of its universal nature. Say you want to log a drone test or something like that. You're out in the wilderness. You may not have access to a charger, but you have access to a Walmart or a gas station where you can get a 9-volt battery. Additionally, we have a coin cell battery, which acts as a backup battery for our real-time clock, which we use for timestamping the data. Now, you can see that the data comes in through something called a Universal Asynchronous Receiver Transmitter, or a UART. We have two of these, one for each of our data streams. From there, it's picked up by something called a Direct Memory Access Controller, which basically moves data from the UART receive buffer into our main memory. The reason we use this is because writing data to an SD card is quite a lengthy process, and we want to use 100% of our CPU power for this. So by using DMA, we save a lot of processor time. From there, it's written to a micro SD card. You can see here our prototype uses something called a ST Nucleo 144 board, and we've attached a micro SD slot and a RS-232 DB9 connector to the board. This is a real-time system, so it's quite a challenge to debug. Often we'll run a test for 30 minutes or more before we start seeing problems. However, real-time development skills are quite valuable in the job market, and so it's worth the effort. Are there any questions?
You touched briefly on this, but can you talk about some real, and for your second semester presentation, you probably ought to think about this. Can you talk about some real life applications and where you'd use this and why it might be better than what's out there now, or what the advantages of it are?
I have another question. Basically, our sponsor gave us a sensor that they produce that is putting out bits of data.
Okay.
Now, they want to be able to log this data in order to track what the sensor is outputting. And the way our sensor is built, we can read any form of computerized data because it puts down what bits are being passed through, not words or any other kind of format. So it's very versatile in that sense.
So, like, again, what would you use it on?
So, for example, our sponsor, VectorNav, they have this development board, and they have a software which they use to program and communicate with the development board. And say you're testing a drone flight, you're sending commands to this device that returns directional information. They need to know if a bug happens, if it happened on the side of the board or on the side of the software.
Okay.
And the best way to know this is to record the communications going from the board to the software and the software to the board. And does not yet exist a solution for this, which we are now working on to create.
Okay. Good example. Okay.
So I'm curious about the selection of the 9-volt battery, and I don't see anything in here other than just like a power block. While it's easy to get a hold of, was there anything else that was driving that particular solution?
That was a solution specifically asked for us to implement by VectorNav, our corporate mentor. So that's why we decided with the 9-volt battery.
Okay, so do you already have at least a paper design of your battery management solution to get it down to something that the other devices on the board can actually use?
We've already connected the 9-volt battery and it works. There's no picture here, but on our poster downstairs, there's a picture with the 9-volt battery that it works, and they also
Okay, so this Nucleo board is already designed to handle.
Yes.
Oh,
Yes.
okay, so the EVA takes care of that for you. So for the next phase, when you're developing your own, that's something that you need to consider, at the very least, looking at what they've done on the board. Usually the schematics are available. And that is a cost, and that's also a cost in terms of power, because you do tend to have some switching losses that are greater than what you would have for lower voltages. But if it's a customer requirement, it's a customer requirement.
All right, thank you very much.